Okay. So, good afternoon to one and all. In the previous lecture, we have discussed regarding three winding transformer. In case of three winding transformer, why it is called as three winding transformer, and what are the advantages and disadvantages of three winding transformer. Also, we have discussed regarding equivalent circuit of a three winding transformer. So, in case of three winding transformer, apart from primary winding and secondary winding, we have connect another one extra winding, that is third one winding. This winding we can call it as a tertiary winding, and due to that tertiary winding, the transformer, it is called as three winding transformer. Again, the voltage rating priority is given for primary winding, having an rating of the voltage, it is nothing but high voltage rating. Tertiary winding having a low voltage rating, and the secondary winding having an intermediate voltage rating between primary winding and secondary winding. Okay, so this is useful while we want to construct the transformer having a high rating, and the construction, it is economical. This is one advantages we have discussed. Construction, it is economical. Also, the efficiency obtained, it is greater. Also, we have discussed another one advantages is that it will be fed the reactive power to the top substation. Also, the most important advantages is that it will neutralize the effect of third harmonic, or it may be odd harmonic, which is generated due to primary winding and secondary winding. Primary winding and secondary winding, it will generate some of the harmonics, that is odd harmonic content, and this harmonic, it is reduced, or it may be it is extinguished by using an third winding, or we can call it as a tertiary winding, so that the three winding transformer, it is useful. Now we will discuss regarding next one point, and it is very important. Also, this is application based point, that means this one is the application based point, and it is important. Also, it is interesting point, that is Scott connection. See, the Scott connection, this is also called as two phase to three phase conversion, or it may be three phase to two phase conversion. Okay, Scott connection, it is nothing but connecting a transformer in a such a way that our three phase power, it can be converted into two phase, or it may be we are able to convert two phase power into three phase. All of you keep in mind. So this is nothing but Scott connection. Suppose in our field, suppose three phase power, it is available, and I want to run my machine on a two phase only. So that such a transformer, it is useful while converting this three phase power to the two phase, that is three phase to two phase conversion, or vice versa, that means two phase to three phase conversion. जर आपल्याला थ्री फेजचं कन्वर्जन टू फेज मध्ये करायचं असेल, or if we want to convert three phase to two phase or two phase to three phase, then the Scott connection, it can be used. So it is used. See here, there are two main reasons, that means why this connection is needed for three phase to two phase conversion, or it may be two phase to three phase conversion. Here are two reasons is given behind that, that means a need of that connection. First one reason is nothing but to give a supply to an existing two phase system from a three phase supply. Suppose our terminal or our end consumer having an three phase supply, and my equipment or my existing system required a two phase system. So at that situation, such connection can be done, that is Scott connection can be done to convert three phase to two phase, to convert a three phase to two phase. Okay, and also second one need, or the second one application for that, it is needed, that is to supply two phase furnace transformer from a three-phase source. Okay, so as you know that the furnace transformer is there, furnace, or we can call it as a arcing transformer. So in case of furnace transformer, supply required in a two-phase supply, it can be required in a two-phase. So if a three-phase source is available and we want to require a two-phase supply, at that situation we connect such a connection like a Scott connection. So this is what it is, important connection, that is Scott connection. If we want to convert three-phase to two-phase, or it may be a two-phase to three-phase. Okay, getting basic idea regarding that?
Yes, sir.
Okay, so it is simple. That means if we want to convert a three-phase to two-phase and vice versa, that means two-phase to three-phase, we are using a Scott connection. That means Scott connection, it is also called as three-phase to two-phase conversion or two-phase to three-phase conversion. Okay, why it is needed? Because our existing system having an one equipment, or it may be one device, it required a two-phase supply. So at that situation, if supply is available in three-phase and I want to use two-phase, at that situation such connection can be done. Okay, similar way, if the furnace is there and the furnace transformer is there, whether you people know the furnace, माहिती का? Don't know furnace? There are some types of furnace, that is arc furnace, heating furnace. So furnace is nothing but one type of heating equipment. Suppose in our sugar factory, if we consider a furnace, आपण शुगर फॅक्टरी मध्ये जर फर्नेस कन्सिडर केलं, सो द बगॅस ऑब्टेन्ड फ्रॉम द शुगर केन, जो काय बगॅस किंवा आपण त्याला भुसा म्हणतो, सो दिस बगॅस इट कॅन बी बर्न इन द फर्नेस. फर्नेस म्हणजे एक बर्निंग इक्विपमेंट असेल. ओके, सो वी वॉन्ट टू ऍडजस्ट द heat by varying this transformer, so that furnace transformer it is required, right? No, furnace is nothing but one type of bagasse kiwa one type of heating equipment. We are adjusting the current flowing from that equipment so that the heat it can be controlled. Okay, किंवा जर शुगर फॅक्टरी मध्ये कन्सिडर केलं तर शुगर केनचा जो काय भुसा असेल तो आपण बर्न करून काय करतो, हीट आणि स्टीम च्या फॉर्म मध्ये वॉटर हीट करतो. दिस कॅन बी फेड टू द टर्बाइन, and turbine it will connected to alternator, and alternator it will generate electricity. Okay, I think you learn, I think you seen or heard about co-generation system. कोजन कारखान्यामध्ये बघा, शुगर फॅक्टरी मध्ये कोजनरेशन किंवा कोजन प्लांट असतो एक. दॅट मीन्स दे आर जनरेटिंग इट्स ओन इलेक्ट्रिसिटी. त्यांना स्वतः लागणारी इलेक्ट्रिसिटी किंवा त्यांच्या जे काही कॅप्टिव्ह पॉवर असेल, local power. So suppose I will tell like one example. Suppose you consider अकलूज शुगर फॅक्टरी. ओके, यशवंतनगरचा जो काय शुगर फॅक्टरी कारखाना आहे, देर आर 33 मेगावॅट एनर्जी जनरेशन. 33 megawatt energy generation. So as we know that for energy generation, whether it is required a water डॅम कन्स्ट्रक्ट केला तर ते वॉटर थ्रू एनर्जी जनरेशन होईल, दॅट इज हायड्रो पॉवर प्लांट. सपोज स्टीम पॉवर प्लांट इज देअर. स्टीम पॉवर प्लांट असेल तर त्याच्यामध्ये स्टीम प्रोड्यूस झाली पाहिजे टू रन द टर्बाइन. सो सिमिलरली इन अकलूज शुगर फॅक्टरी देअर इज अ 33 megawatt जनरेशन इज देअर, and in that 33 megawatt generation the bagasse from the sugar cane it will be burned first. पहिल्यांदा तो काय केला जातो, बर्न केला जातो, म्हणजे त्याच्यापासून हीट प्रोड्यूस केली जाते. इन्स्टेड ऑफ युजिंग कोल, कोळसा यूज करण्यापेक्षा शुगर फॅक्टरी मध्ये काय करतात, रॉ मटेरियल फ्रॉम शुगर केन इट कॅन बी बर्न आउट. ओके, आणि जनरली जो काय स्टीम पॉवर प्लांट किंवा आपण थर्मल पॉवर प्लांट म्हणतो, सपोज इफ यू कन्सिडर द पॉवर प्लांट फ्रॉम परळी, परळीचा जो काही थर्मल पॉवर प्लांट आहे there are we are using a kolsa. So in that the steam it can be generated, and this steam it can be fed to that of turbine. Turbine ला काय केली जाते, फेड केली जाते to rotate it. स्टीम म्हणजे जो काही फर्नेस असेल जिथं आपण काय म्हणतो त्याला जाळ तयार करतो किंवा बर्न करतोय बघ्यास. at that situation there are some water tubes are provided. पाण्याचे ट्यूब्स प्रोव्हाइड केलेले असतात. ड्यू टू दॅट हीट water in that tube it get heated and the steam it will be formed. Hot steam it will be formed, and this steam it can be given to that of turbine, and then turbine it will be rotated. So there are some pressure and velocity it can be given, and due to that pressure and velocity the turbine it will be start rotating. It is coupled with that of generator. So generator it will generate some of the electricity, okay, according to their capacity. Okay, so see, this is nothing but concept related to furnace. That is, furnace is nothing but one of the heating equipment. So it will require a two-phase furnace transformer is there. So to feed the power two-phase, we require these types of conversion, that is Scott connection. Okay, see, the two-phase system can have a 3-wire, 4-wire or 5-wire. जी काय टू फेज सिस्टीम असेल, whether it may be we can convert two phase system by using a 3-wire. 3-phase सप्लायच्या 3 वायर असेल त्याच्यावरून पण आपण 2-phase सप्लाय करू शकतो. 4-wire system is there, that means 3-phase and 1 neutral terminal is there. Then also we are able to convert it into 2-phase and 5-wire circuit also. So see, it is needed to be considered that a 2-phase system is not a 2/3 of 3-phase system. Okay, so see, we will not consider that the 2-phase system, that means voltage it will be 2/3. We don't consider like that, because in case of 2-phase system, the in balanced 3-phase wire we want to convert a 2-phase circuit only, but 2 phases both carrying the approximately same amount of current. Okay, सो 3-फेज सिस्टीम मधले वरच्या जो काय 2 फेज असतील किंवा आपण R2B कन्सिडर कराल, R2Y कन्सिडर कराल, इट विल कॅरी both the wires, it will carry a same current, with the neutral wire carrying a 1.414 times the current in the phase wire. फेज वायर मध्ये जो करंट आहे त्याच्या 1.414, that means √2 times current. I think √2 times current it will be flowing from a phase wire. Okay, so this is nothing but the neutral wire. Suppose as you know that in our agriculture field one of the motor is there, that is 2-phase motor. heard की कुणी ऐकली का 2-phase motor? 2-phase motor असते. काय करतो आपण त्याच्यामध्ये, and I want to run this motor on single phase also and 3-phase also. 3-phase वर सप्लाय आल्यानंतर पण आपण रन करू शकतो, आणि सिंगल फेज सप्लाय असल्यानंतर पण आपण रन करू शकतो ना. हा, सांगा, ऐकली का 2-phase motor? That means instead of single phase we are taking 2 phases. सप्लाय कडून येणाऱ्या 3-phase मधल्या 2 phase घेतो, and third one phase there are one capacitor is used. Okay, so supply taken from one phase it can be fed to the third phase via capacitor. Capacitor चा यूज करून आपण काय करतो, तिसऱ्या फेजला सप्लाय देतो. So our 2-phase motor it will be run when there is a 3-phase supply is there. 3-phase supply असल्यानंतर 2 phase चे 2 टर्मिनल घेतले की मोटर काय होते, रन होते. So like that, if we want to convert, or if we want 2-phase system, if the 3-phase supply is available, then we are able to use the Scott connection. Okay, see, the 3-phase to neutral voltage are 90° out of phase with each other. Now in a 2-phase 4-wire circuit, this is a 3-wire circuit. In a 2-phase 4-wire circuit, essentially just 2 ungrounded single phase circuits that are electrically 90° out of phase. Okay, see, 4 वायरची सिस्टीम आहे. सपोज द 4 वायर सिस्टीम इज देयर 1 2 3 and 4. इन दॅट 2 अनग्राउंडेड सिंगल फेज सर्किट, याच्यामधल्या 2 ज्या वायर्स असतात त्या अनग्राउंडेड असतात and 2 वायर्स आर ग्राउंडेड. So this grounded wire is nothing but neutral wire, and these 2 wires are the phase wires. Okay, so 4 wire circuit are essentially just 2 ungrounded single phase circuit that are electrically 90 degree out of phase which each other. म्हणजे या फेजचं व्होल्टेज and या फेजचं व्होल्टेज, suppose if we represent VA and VB, so these are 90 degree apart from each other. ते एकमेकापासून किती apart असतात? It will be apart 90 degree apart from each other, and the 4 wires each other, and 2 phase 5 wire circuit have 4 phase wires. 2 phase 5 wire circuit, I have tell here 3 phase 4 wire, 3 phase, that is 3 wire, 3 phase 4 wire, as well as 5 wire circuit is there. So in case of 5 wire circuit, it is having an 4 phase wire plus a neutral wire. 5 wire circuit मध्ये काय असतात? 4 phase wire and one of the neutral wire. Okay, so and the 4 phase varies are 90 degree out of phase with each other. याच्यामधल्या प्रत्येक फेज आहे, सपोज VA, VB, VC, these are 90 degree apart from each other. VA apart from VB 90 degree. Similarly, VB apart from VC, it is 90 degree. Okay, 90 degree phase difference असेल each and every मधला. So these are the different types of wire system. From that different types of wire system we are able to convert it into 2 phase. Okay, 2 phase मध्ये आपण काय करू शकतो? कन्वर्ट करू शकतो, or we are able to convert it into 3 phase also. See the Scott connection. What is the Scott connection? See the Scott connection, or it is called as Schottky transformer. It is a type of circuit used to convert a 2 phase power from a 3 phase source, or it may be vice versa. Okay, जर आपल्याला 3 phase सिस्टीमचं कन्वर्जन 2 phase मध्ये करायचं असेल, or if we want to convert a 3 phase source into a 2 phase, at that situation we are able to use a Scott connection. So Scott connection evenly distribute a balanced load between the phases of the source. Okay, if we done the Scott connection, so at that situation it will evenly distribute the load. So this is most important point. What will happen? See here, in the yesterday lecture we have discussed regarding any one of the faults. Suppose 3 phase system is there, unbalanced loading we have discussed. Unbalanced loading आपण already discuss केलेलं आहे. See, suppose this is a 3 phase system or 3 phase 4 wire system we consider. 3 phase 4 wire system consider केली. In the previous one I have already discussed, if single phase motor, it can be connected into 3 phase system. At that situation what happen? The load on any one of the phase, it will be increases. ज्याला ती मोटर कनेक्ट केलेली आहे त्याचा लोड काय होईल? Increase will. That means it will take extra amount of current from the supply. बरोबर ना? See, जर ही लाईन आहे असं कन्सिडर करा आपली ऍग्रिकल्चर फील्डची. याच्यामध्ये पॅरलल मध्ये सपोज मी 3 मोटर कनेक्ट केलेले. 3 मोटर मधली 2 मोटर माझ्या 3 फेज आहेत and 1 motor having an single phase motor. Suppose when the 2 motors are running, ज्या 3 phase सप्लाय वरती रन होणाऱ्या मोटर आहेत, if these motors are running, it will take a balanced current from each 3 phase. At the same time, if single phase motor it is also running, single phase motor पण त्या सेम टाइमला रन होत असेल तर ज्या फेजला ती कनेक्ट केलेलं आहे, current flowing from that phase it will be increases. Right? No, this is simple funda. That means current flowing from that phase it will be increases. That is unbalancing it will be occur. Right? No, that means unbalanced current it will be flowing from phases. Due to that unbalanced current, what will happen? Somewhat fault it will be occur. If the fault occur, जसं मी स्टार्टरच्या कंडिशन मध्ये सांगितलं होतं तुम्हाला किंवा एखादा स्टार्टर न यूज करता डायरेक्टली लाईनला मोटर कनेक्ट केली, so such that the unbalancing in the current it will be occur, and due to that unbalancing this machine it will be get damaged. Also other equipment which are connected on the same system it will also damage होऊ शकतात ना अनबॅलन्सिंग झालं तर. So see, for that reason the Scott connection is useful, because if we do the Scott connection while converting three phase to two phase, so it will provide a balanced load between the phases of the source. म्हणजे सोर्सच्या जर 3 फेज असतील आणि मी 2 फेज लोड कनेक्ट केलेला आहे, also it will provide a balanced load current in all 3 phases of the system. तिन्ही फेज वरती काय होईल, त्याचा बॅलन्स्ड करंट फ्लो होईल. ओके, so that's why, or that's reason we are connecting a Scott connection, or we are doing the Scott connection. See, we will discuss how the Scott connection it can be done. I will show the figure next. See, the Scott connection or the T transformer, it will require a 3-phase power input, and it will provide a 2 equal single phase output, so that there are called as a main and a teaser. That means there are 2 single phase transformer it can be used. By using a 2 single phase transformer, we are converting these 3 phase to 2 phase. आपल्याला 2 single phase transformer पाहिजे. By using a these 2 single phase transformer, we are converting this 3 phase power into 2 phase power. Okay, 3 phase power चं कन्वर्जन आपण काय करतो, 2 phase मध्ये करतो by connecting a 2 single phase transformer. 2 single phase transformer चा यूज करून काय करतोय, कन्वर्ट करतो. See, in that 2 single phase transformer, one transformer it is called as main transformer, and the second one transformer it is called as teaser transformer. एका ट्रान्सफॉर्मरला आपण टीजर ट्रान्सफॉर्मर म्हणतो, and one transformer it is called as main transformer. त्याच्यामधला एक मेन ट्रान्सफॉर्मर असेल, and one is nothing but teaser transformer. Okay, one is nothing but main and one is nothing but teaser transformer. See, this main transformer and teaser transformer are 90-degree out of phase. मेन ट्रान्सफॉर्मरचं व्होल्टेज आणि teaser transformer voltage, it is 90-degree apart from each other. That means out of phase 90-degree. Suppose voltage of the main transformer VA, main transformer voltage VA असेल, and the teaser transformer voltage VB असेल. So these are 90-degree apart from each other. ते एकमेकापासून 90-degree apart. Now why it is called as teaser transformer or T transformer? The connection shape it will be like as a T shape, so that we can call it as a T transformer, or it may be teaser transformer. Okay, see, the main and teaser output must not be connected in parallel or in series, as it's create a vector current imbalance on the primary side. So there is a no parallel connection, or it may be no series connection, because it will create a vector current imbalance. Main and teaser outputs are on separate core. मेनचा आउटपुट and teaserचा आउटपुट हे काय असेल, or सेपरेट कोर वरती असेल. So an external jumper is also used. That means we are using a one jumper wire, that is external jumper wire. It is required to connect the primary side of the main and the teaser section. Teaser section ची आणि main ची primary side connect करण्यासाठी आपण jumper wire use करतो. So see the diagram for that, we will show that diagram, that is Scott connection. Okay, see here, this is the connection of Scott, or it may be 3-phase to 2-phase conversion. See, in that there are 2 transformer it can be used. One transformer it is called as main transformer, and second transformer it is called as teaser transformer. In case of main transformer, input to that of transformer it is connected to 3-phase supply. याचं इनपुट किती फेज सप्लायला कनेक्ट केलेलं असतं, काय कन्वर्जन करतोय आपण, hello,
3-phase to 2-phase.
3-phase to 2-phase, that means 3 terminals in the input side and 2-phase output at the secondary side, right? No, secondary side ला काय पाहिजे, 2-phase output पाहिजे, primary side ला 3 phases connection पाहिजे. Okay, see, the Scott connection, or we can call it as a T-type connection, is the method of connecting a 2 single phase transformer to perform the 3-phase to 2-phase conversion and vice versa. 3-phase conversion 2-phase मध्ये करायचं असेल, or vice versa is nothing but if we want to convert 2-phase to 3-phase, then we are using a 2 single phase transformer to perform this function. See, in that these 2 transformer are connected electrically but not magnetically. हे जे काय 2 transformer आहेत, so these 2 transformer which are connected, that means which are connected electrically but not connected magnetically. जे आपण 2 single phase transformer connect करतोय, so these 2 transformer, it is not connected magnetically, it is connected electrically. त्याच्यामध्ये इलेक्ट्रिकल कनेक्शन असेल, त्या 2 ट्रान्सफॉर्मर मध्ये मॅग्नेटिकल कनेक्शन नसेल. ओके, all of you understood that concept? That means these are not connected magnetically but it is connected electrically. त्याच्यामध्ये इलेक्ट्रिकल कनेक्शन असेल, मॅग्नेटिकल कनेक्शन असेल. See, in that this one is the teaser transformer. त्याच्यामधला कोणता टीजर ट्रान्सफॉर्मर आहे? Can anyone able to tell which one is teaser and which one is main transformer? कोणता आहे डायग्राम मधून लक्ष देते का?
Phase 1.
Which one? Phase 1. A phase का? This one is which transformer?
3-phase side is a teaser transformer.
Total 3-phase side is teaser transformer, right? No, असं म्हणायचं ना? असं सांगायचंय का? Total 3-phase side it is a teaser transformer.
Yes, sir.
Okay, see, first of all understood the transformer. Transformer, it is nothing but it is having an primary winding and secondary winding. Single phase transformer जर consider केला तर त्याला primary winding पाहिजे, again it is secondary winding पाहिजे. Similarly, another one single phase transformer, if we consider, it is having an primary winding, also it is having an secondary winding, right? No, now these 2 transformer, आता याच्यामधला एक मेन आहे असं कन्सिडर करा, याच्यामधला एक टीजर आहे असं कन्सिडर करा, right? No, see, these 2 transformer are not magnetically connected. त्याची प्रायमरी आणि सेकंडरी मॅग्नेटिकली कपल्ड राहील, त्याच्यामध्ये मॅग्नेटिकल कनेक्शन असेल ना. त्याच ट्रान्सफॉर्मरची प्रायमरी आणि सेकंडरी सेम ट्रान्सफॉर्मरची प्रायमरी आणि सेकंडरी, वेदर देयर इज अ मॅग्नेटिकल कनेक्शन इज देयर ऑर नॉट. सेम ट्रान्सफॉर्मरची प्रायमरी आणि सेकंडरी मध्ये
Yes, sir.
देयर इज अ म्युच्युअल इंडक्शन प्रिन्सिपल. नो, secondary side ला EMF induce व्हायला पाहिजे, so that these are the magnetically connected, that means these are constructed on common core. Common core वरती काय केलेले असतील, construct केलेले असतील. Okay, see what sentence I have tell, the 2 transformer are connected electrically but not magnetically. हे 2 जे ट्रान्सफॉर्मर आहेत, हा एक ट्रान्सफॉर्मर आणि हा एक ट्रान्सफॉर्मर. These 2 transformer are not connected magnetically but it is connected electrically. So now can anyone able to tell which one is the main and which one is the teaser? सांगता येईल का? Okay, let it be. See, this transformer above side, this two winding, हे जे दोन winding दिसतात, this transformer, it is nothing but teaser transformer. Teaser transformer, primary winding of the teaser transformer, secondary winding of the teaser transformer. And this transformer, हे जे काय दोन winding आहेत, 0.5 TP, 0.5 TP and TS, these are the main transformer. Okay, so this one is the main transformer. This one is the main transformer, that is the primary winding of main transformer, it is this one, and the secondary winding of the main transformer, it is this one. लक्षात आलं? Now see whether there is any magnetic relation between primary and any magnetic relation between teaser and main transformer.
No.
But there is a electrical connection or not?
Yes.
Yes, sir.
Okay, see here it is electrically connected, direct connection केलं आहे, इथं electrically connect केलं आहे दोन transformer, there is a no magnetically connection. So all of you understood the meaning. The two transformer are connected electrically but not magnetically. So one of the transformer is called as main transformer and the other is called as auxiliary, or we can call it as a teaser transformer. So the figure for Scott connection, it can be shown in this figure. See, the main transformer primary winding, main transformer winding, or it may be main transformer primary winding, it is center tapped. मेन ट्रान्सफॉर्मर जो आहे कोणता आहे मेन ट्रान्सफॉर्मर? विच वन इज मेन ट्रान्सफॉर्मर? हा ना, डाउनवर्ड साइडचा, राइट नो? सो दिस इज द मेन ट्रान्सफॉर्मर. सो प्रायमरी वाइंडिंग ऑफ दिस मेन ट्रान्सफॉर्मर, इट इज सेंटर टॅप्ड. व्हॉट इज टॅपिंग? सांगितलं मी. टॅपिंग इज नथिंग बट जस्ट कनेक्शन अँड इट इज सेंट्रली टॅप्ड. म्हणजे प्रायमरी वाइंडिंग जर 100 नंबर ऑफ टर्न्स असतील, see if there are 100 number of turns on the primary winding, या जर 100 number of turns असतील तर याच्या सेंटरला काय केलंय? टॅप केलंय. म्हणजे तिथं टीजर ट्रान्सफॉर्मरचं वन टर्मिनल काय केलंय? कनेक्ट केलंय. सो द प्रायमरी वाइंडिंग ऑफ द मेन ट्रान्सफॉर्मर, इट इज डिवाइडेड इनटू टू पार्ट. गेटिंग व्हाट आई एम टेलिंग? हॅलो.
Yes, sir.
Yes, sir.
हा, ट्रान्सफॉर्मरची प्रायमरी वाइंडिंग जी आहे मेन ट्रान्सफॉर्मरची, इट इज डिवाइडेड इनटू टू पार्ट. सपोज consider the total number of turns of the primary winding, it is nothing but TP. So it is divided into two parts because it is centrally tapped, so that TP by 2 turns obtained on one side and TP by 2 turns obtained on other side. That means 0.5 TP and 0.5 TP it can be obtained. बघा इथं दिलेलं आहे 0.5 TP turns on this side, 0.5 TP turns on this side. So see, teaser transformer चं one terminal जे आहे, one terminal of the teaser transformer, it is connected to the line through a winding, that is primary winding of teaser transformer. We can call it as a TP of teaser transformer. And another one terminal of this teaser transformer, it is connected to the center tapping point. It is it is connected to the center tapping point where the primary winding of the main transformer, it is divided into two parts. So here there is a electrical connection, it can be done. त्याच्यामध्ये इलेक्ट्रिकल कनेक्शन केलेलं आहे बघा. सो याचं जे काय नेक्स्ट टर्मिनल असेल याच्या प्रायमरी वाइंडिंगचं टीजर ट्रान्सफॉर्मरच्या, इट इज कनेक्टेड टू द टॅपिंग पॉइंट. टॅपिंग पॉइंटला काय केलेलं असेल? कनेक्ट केलेलं आहे. सो सी, इट हॅज द प्रायमरी एडी, इट हॅज द प्रायमरी एडी अँड द सेकंडरी B1 B2. सी, द टीजर ट्रान्सफॉर्मरची प्रायमरी कुठून कुठेपर्यंत झाली आता बघा. सपोज ए टर्मिनल इज दियर, ए टर्मिनल पासून डी पॉइंट पर्यंत जी काही वाइंडिंग असेल इट इज नथिंग बट प्रायमरी वाइंडिंग ऑफ टीजर ट्रान्सफॉर्मर. राईट नो?
Yes, sir.
लक्षात आलं?
Yes, sir.
Primary winding of teaser transformer is nothing but from terminal A to D there are how many winding? It is nothing but winding of teaser transformer on the primary side. Similarly, B1 B2 it will be represented, B1 and B2 it will be represented as a secondary of the teaser transformer. So this is the TS of the teaser transformer. This one is the TP of the teaser transformer. How much value of TP it can be obtained? We will derive that next one. See, this is central tap. All of you understood the connection. Baga, A terminal, it is nothing but one line terminal. 0.5 TP winding, it will be act as a B phase, or it may be, and this connection, central tap nantar je winding rail, it is nothing but another one connection, that is C terminal. That means this by electrical connection or by doing the electrical connection we have taken out three phases. That means for this is three phase supply. Three phase supply साठीचे हे तीन terminal निघाले. On the secondary side, teaser transformer having an secondary winding. Teaser transformer it is having an secondary winding. Similarly, main transformer having an secondary winding. Secondary winding आहे. These are the single phase transformer. One phase load it can be connected here, one phase load it can be connected here. That means two phases. So conversion three phase to two phase. Three phase पासून two phase कडे काय आहे? Conversion आहे. So conversion of this it is nothing but the three phase to two phase. Three phase पासून two phase पर्यंत काय आहे? Conversion. Okay. See, the identical and interchangeable transformer are used for Scott or T connection, in which each transformer has a primary winding of TP turns. प्रत्येक ट्रान्सफॉर्मरच्या जे काही प्रायमरी वाइंडिंग असतील इट इज हॅव्हिंग अन TP turns and is provided with tapping at 0.289 TP, 0.5 TP and 0.866 TP. That means primary number of turn च्या 0.5 ला टॅपिंग आहे, 0.86 TP ला काय आहे टॅपिंग आहे. See this figure or it may be this connection like as a T safe. हे कसं आहे कनेक्शन? असं जर उलट कन्सिडर केलं तर वेदर इट इज T or not?
Yes, sir.
Okay, so this connection it is like as a T safe, so that we can call it as a teaser or it may be Scott connection or it is T connection. त्याला आपण T connection म्हणू शकतो किंवा Scott connection म्हणू शकतो. Okay, see now we will derive. Do you know that the phase voltage on the three phase side चे जे काय phase voltage असेल or it may be line voltage. See, line voltage of the three phase side, here it is, this voltage is nothing but VAB, this voltage it is nothing but VBC, and this voltage it is nothing but VAC. Okay, so these three voltages in the previous one we have discussed, it will like a balanced voltages. That means there is a no unbalancing occur, there is a balanced voltage it will be occur, so that we can write, आपण लिहू शकतो VAB is equals to VBC, it is equals to VAC, it is equals to, this is balanced voltage. So instead of writing separate voltage, I am writing here VL volt at an angle 0 degree. Okay, so that means a balanced voltage. Okay, so see, if we want to draw the phasor diagram, if we consider a B phase as a reference phasor, जर आपण B phase ही reference phasor consider केली, and if we draw the phasor diagram, so phasor diagram it will be like this. Suppose this is the one reference phasor, that is VBC. Okay, one B to C, B पासून C पर्यंत जे काय voltage असेल, if we taken as a reference phasor, So there is a balancing, that means there is a no unbalancing or unbalanced, so that angle between each and every voltage, how many angle, किती डिग्री ना अपार्ट असतात ते बॅलन्स्ड फेजर?
90 degree.
90 degree. VAB,
120.
VBC and VCA or VAC.
120.
याच्या दोन्हीच्या मधला अँगल फॉर बॅलन्स्ड सिस्टीम सांगितलं मी त्या दिवशीच. For balanced three-phase system, the angle between these two phases or these two voltages is nothing but 120 degree. So balanced, this one is also 120, this one is also 120, so total is nothing but 360. So round झाला ना. So the balanced phasor, the angle between each is nothing but 120 degree. Okay, angle between it is nothing but 120 degree. See, this is the phasor. For that I will draw the voltage between B to C. It is nothing but voltage between B to C. It is nothing but VBC. Suppose I will draw here one triangle. एक जर मी ट्रायंगल ड्रॉ केला, that is B terminal to C terminal. Here it is B terminal and here it is C terminal. So it is nothing but one of the voltage we have derived here. Now this BC voltage, or it may be BC turns, it can be centrally divided. ते काय केलेले आहेत? सेंटर टॅपिंग केलेलं आहे किंवा सेंट्रली डिवाइड केलेलं आहे, याच्यावरून ड्रॉ करतोय आपण. सी सपोज B to C, it is nothing but this voltage, it can be obtained. हे जे व्होल्टेज आहे ते B to C ऑब्टेन झालेलं आहे. Now this voltage or this turns, it is centrally tapped. Suppose it is centrally tapped, centrला टॅप केलेलं आहे म्हणजे D पॉइंटला टॅप केलेलं आहे. So voltage occurs due to that winding, that is teaser transformer winding is nothing but, suppose this is voltage, right? No, this voltage is nothing but voltage VAD or one vector VAD. Vector VAD is nothing but this voltages. Now we want to calculate the voltage V A to B. A to B is nothing but voltage काय आहे? Suppose this is A point. A to B voltage is nothing but VAB. Suppose I have drawn here, this is the VAB voltage or VAB vector. Similarly, A to C is nothing but this one is the VAC voltage. Baga. So this is one balanced phasor we have derived. That is, suppose we have considered one of the BC is voltage B to C is nothing but one balanced vector or balanced phasor. This BC, it is divided or it is centrally tapped. So at a point D, D ला काय केलेलं आहे ते सेंट्रल टॅपिंग केलेलं आहे. किंवा इथं जरी तुम्ही कन्सिडर केलं, सपोज इथं मी A टर्मिनल देतो, हे व्होल्टेज इज नथिंग बट A to D, या दोन्हीच्या मधलं व्होल्टेज काय आहे? A to D आहे. नाव इथं जर मी B टर्मिनल नाव दिलं, इथं C केलं, B to C इज नथिंग बट दिस व्होल्टेज B to C सेंट्रल टॅप केलेलं आहे. अगेन A to B मला कॅल्क्युलेट करायचं आहे, दिस इज नथिंग बट A to B, राईट नो. आणि C जर इथं हा हे टर्मिनल, याच्यामध्ये काहीच नाही. सो सपोज आय एम रिप्रेझेंटिंग C हियर, सो दिस विल बी लाईक ॲज अ A to C, VAC. ओके, सो सी दिस इज वन ऑफ द फेजर. ही फेजर आहे बघा, फेजर डायग्राम. B to C, it is nothing but reference phasor. This reference voltage, it is centrally tapped at a point D, and VAD is nothing but voltage obtained due to that of primary winding of teaser transformer. VAB is nothing but voltage between terminal A to B, and VAC, it is nothing but voltage between terminal A to C. Okay, now from this equation or from this phasor diagram, we want to derive how many turns it will be present on this teaser transformer. या teaser transformer मध्ये किती number of turns असतील हे आपल्याला कॅल्क्युलेट करायचं. सो हियर इथं लिहिलेलं आहे बघा, √3/2 TP म्हणजे प्रायमरी नंबर ऑफ टर्नच्या मेन ट्रान्सफॉर्मरच्या ज्या काय टोटल नंबर ऑफ प्रायमरी नंबर ऑफ टर्न्स असतील त्याच्या रूट 3/2 टर्न्स ह्या टीजर ट्रान्सफॉर्मरच्या प्रायमरी वाइंडिंगला असते. ते आपल्याला डिराईव्ह करायचं याच्यावर. सी ऑल ऑफ यू ड्रॉ ऑन दिस फेजर. फेजर ड्रॉ करा ऑल ऑफ यू. झालं. ओके सी. हा लक्ष द्या थोडस. सी now we have written here VAB, VBC, VCA is nothing but balanced phasor, so that we are writing as a magnitude VL at an angle 0 degree. See, BC it is taken as a reference phasor, so we can write VBC it is equals to VL at an angle 0 degree. Now suppose I want to write VAB. VAB it is equals to, again it is magnitude VL, so instead of writing VAB I am writing VL, and angle between this reference phasor हा आहे आणि याच्यामधला अँगल किती आहे? अँगल किती? 120 डिग्री. प्लस और माइनस? प्लस का माइनस? लीडिंग आहे का लॅगिंग आहे? हा रेफरन्स फेजर आहे. या रेफरन्स फेजर पासून हा लीडिंग आहे का लॅगिंग आहे? हे व्होल्टेज leading, no, so that we can write here plus 120.
Yes,
and VAC it is lags behind by this reference phasor 120 degree, so that it is written as a VAC is nothing but VL at an angle minus 120 degree, right? No, so this is conclusion from this phasor diagram. Now see, the voltage BC it is divided at a central point D, or it is tapped at a central point D, so that the turns used in the BC it is also centrally tapped. BC च्या टर्न पण काय आहेत? सेंट्रल टॅपला आहेत ना. नंबर ऑफ टर्न्स मी काय सांगितलं मगाशी, नंबर ऑफ टर्न्स जर 100 असतील त्याच्या डिवाइड झाल्या म्हणजे 50 टर्न्स या साइडला, 50 टर्न्स या साइड, सो दॅट द टर्न्स ऑब्टेन्ड फ्रॉम B to D, that is voltage B to D, it is equals to voltage D to C, it is equals to TP by 2, that is VBD टर्न सांगितल्या मी हाफ, so that voltage obtained it is also half of that of BC. BC व्होल्टेजच्या हाफ व्होल्टेज मिळेल, म्हणजे B2 पासून C पर्यंत व्होल्टेज 100 असेल, तर B to D पर्यंत व्होल्टेज किती असेल? 50. D to C पर्यंत व्होल्टेज, that means we have written here VBD is equals to VDC, it is equals to TP by 2, it is equals to 1/2 VBC. VBC चा हाफ असेल, right? No, VBC चा हाफ. So instead of writing VBC, I am writing here VBC is taken as a reference, so 1/2 VL at an angle 0. लिहू शकतो का मी?
yes, sir.
Okay. Now I think this is a graphical or mathematical part. ह्याच्यामध्ये ट्रिग्नोमेट्री मध्ये झाला असेल तुम्हाला. Now I want to calculate the voltage VAD. I want to calculate the voltage VAD. मला आता VAD व्होल्टेज काय करायचंय? कॅल्क्युलेट करायचं. कोणती प्रॉपर्टी यूज होती? A पासून D पर्यंत व्होल्टेज. Which one property?
Pythagoras theorem.
Pythagoras theorem पण यूज करू शकतो ना. So
Yes,
see,
sir.
in the triangle centrally tapped, so summation of these two, या दोन्हीचं घ्या किंवा या दोन्हीचं घ्या, A to B and B to D, it is nothing but VAD. So VAD is nothing but voltage VAB plus voltage VBD. So put the value of VAB. VAB ची व्हॅल्यू काय आहे? VL at an angle 120 degree plus what is the value of VBD? VBD ची व्हॅल्यू काय? VBD is here. Value of that is nothing but 1/2 VL at an angle 0 degree. Right? No, at an angle 0 degree. So just calculate the value. Take VL common आणि व्हॅल्यू कॅल्क्युलेट करा. at an angle 120 degree काय येते व्हॅल्यू? कसं लिहितो आपण? काय लिहिता व्होल्टेज? PL at an angle 120 degree. अँगल थिटाचं कन्व्हर्जन कसं करतो? R plus JX च्या फॉर्मॅट मध्ये करता येतं, माहिती ना? सो दिस थिटा म्हणजे पोलार क्वांटिटीचं कन्व्हर्जन रेक्टँग्युलर क्वांटिटी मध्ये. कॅल्शियम मध्ये डायरेक्टली येऊन जाईल, तुम्हाला व्हॅल्यू येईल. सो व्हॅल्यू इट इज नथिंग बट -1/2. म्हणजे बघा हे कसं लिहितो आपण? थिटा मला जर याच्या फॉर्म मध्ये कन्वर्ट करायचा असेल तर तो कन्वर्ट केला जातो कॉस थिटा प्लस जे साइन थिटा. सांगा cos 120 किती येते व्हॅल्यू? cos 120
-half.
-half. and sin 120 sin 120. See, it will come -1/2 plus j sin 120 किती येते? 1.17 येते का? किती येते व्हॅल्यू?
0.866.
0.86. 0.86 is nothing but √3/2. √3/2 plus 1/2 VL at an angle 0. So see, -1/2 VL इथून लिहितोय मी, VL ना मल्टिप्लाय केलं, -1/2 VL प्लस j √3/2 VL प्लस 1/2 VL. याच्यामधला हा 1/2 VL -1/2 VL गेट कॅन्सल. रिमेनिंग टर्म इट इज नथिंग बट j √3/2 VL. j √3/2 VL. So j √3/2 VL it is nothing but √3/2 किती आलं? 0.866 ना?
0.866. Yes, sir.
866 VL म्हणजे, आणि जे ची व्हॅल्यू इज नथिंग बट ॲट अन अँगल 90 डिग्री. जे म्हणजे काय असतं? ॲट अन अँगल 90 डिग्री. So phase difference between that is nothing but 90 degree phase difference. So this 0.866 VL it is nothing but number of turns. कशाची व्हॅल्यू आली ही?
VAD.
VAD is nothing but voltage across these two. कुठून? A पासून D पर्यंत. A पासून D पर्यंत व्होल्टेज इज नथिंग बट A to D व्होल्टेज it is nothing but 0.866 VL. So meaning of that, 0.866 number of turns it will be present compared to that of turns of मेन ट्रान्सफॉर्मरच्या टर्न्स जर टीपी असतील तर त्याच्या 0.866 टाइम्स टर्न्स ह्या ए टू डी असतील, म्हणजे टीझर ट्रान्सफॉर्मरच्या टर्न्स असतील. ओके, गेटिंग?
Yes, sir.
ओके, सोल्युशन लक्षात आलं?
Yes, sir.
Okay, so this is related to two phase to three phase conversion, or it may be three phase to two phase conversion. So some of the application of these types of transformer, advantages and application, we will discuss that advantages and application in the next lecture. In this way we will conclude this today's lecture, and we will stop here. Thank you.